Alright, this one is a Bridgehead motor that I designed with the help of a friend, Dave. So, imagine Dave will watch this since I'm putting it up for Dave, technically, so he can see with an explanation on it. Now, I'm going to call this version, this is a really rough version, but this is a Bridgehead motor is what it is. This will be stacking V-gates with internal combustion. It'll be a Bridgehead. That way, fuel usage would be cut down by about 50%, while the actual horsepower and torque is retained. Now, this is two V-gates that are at 90s to each other. It's just, again, it's just an idea. So we'll begin with my first photo, or my first design here. Unfortunately, I screwed up and I didn't save it without the fuel and airflow. You know what I mean. But anyway, so we'll go left to right, top to bottom. Okay, so on the left-hand side there, it'll show fuel and airflow. Fuel's red, air is orange, and crank gases are green. All right, so focus on your red right now. The tank, it's the box on the very far left-hand side by itself, is actually a primer bulb. It's just a real generic design. Primer bulb on a pressurized fuel tank. Okay, I'll show you how it works here in just a second. But the fuel is injected through the fuel line into what you can't see it. You'll see it in the next version, but or the next setup. But that's a carburetor. That's a pressurized carburetor that's going to act as an impeller or a turbo jet in a way. Okay, now that's for fuel atomization in order to increase fuel burn but decrease fuel usage. Okay, the more you atomize it, the more you bust it down, because remember, kids, firing chambers and internal combustion engines do not burn liquid. It burns vapor. Okay, so it's got to be vaporized. Depending on how you want to do it, everything from heating it to so on and so forth. This will be a mix. All right. Okay, anyway, so the fuel comes out of the tank, passes through the impeller. I'm just going to call it an impeller for now, turbojet, however you want to call it. And then it's passed into the firing chamber. Right at the top of the firing chamber, the blues are magnets. You'll see them. Those lines, those blocks are magnets. That's correct. There'll be magnetic buffering. Those are not the actual V-gates. The red circles represent V-gates. But this is two-dimensional, and it's not three-dimensional. I haven't gotten it into three-dimensional design yet, but that's okay. That's not the point. It's a design. Anyway, at the top of the firing chambers, your standard spark plug leads off to the magneto, red with the black box in it. I ain't going to explain magnetos to you. You ought to know how they work. Anyway, passes through, and of course any unburnt fuel passes to the right-hand side out of the exhaust port. Standard. It's two-stroke motor. Okay, standard. But this is a two-stroke V-gate design. Now, at the top of the piston, you're going to have your top buffer, your top dead center magnetic buffer, okay? And at the bottom of the piston, you'll have the bottom dead center, but technically not dead center. But anyway, you'll have your magnet buffer on that, and then, of course, further down, as you go down, you'll have your three angled. They're going to act as a slider, a magnetic slider. The fields will be ablative, so they'll act. So it'll help slide the piston down as she goes. Okay. Remember that we're not trying to eliminate fuel in these versions. What we're trying to do is eliminate at least lessen how much fuel. So moving down, when she reaches the bottom, well, if you'll look at the bottom there on the crank case on the bottom side, the flywheel there will also have drive magnets, and of course it'll have another section of a V-gate. And moving to the bottom left, you'll have a actual gas piston that's impeller driven, which is magnet on magnet. It's not physically touching, and it'll be tiny. That creates your compression air to spin up your turbojet. Okay, don't laugh, or your impeller. Okay, so it forces the air back up. You can see it. It'll pull crankcase gas from the bottom side, which is also helped because it's going to be compressed on bottom dead center of the piston when she reaches bottom. Okay, it's going to dump it back into the carb. Okay, and the carb's got a bottom side impeller for the butterfly plate, and it's also got a port for fresh air right there, but we'll get into that in the next version. Your green is your crank gas, as you can see. Even though I split it into two, technically it's just a dump port, so when the piston reaches bottom dead center, it'll shove crankcase gas pressurization back into the fuel tank. Now, if you're wondering, on a two-stroke motor, because of the oil and everything, you have to go, I think it's 50 to 1 now, 50 to 1 oil gas mix. So when that's also what lubricates your crankcase or your bearing, your roller bearing for your rod. Okay, I'm not going to explain any of this. All right, so for your rod and for your crank bearing, that's what's going to do the lubrication there. So since it's that simple, what you'll do is pass those vapors, when they get pressurized on the bottom half, back into the fuel tank and pressurize the fuel tank. And when you do that, it'll be the same as passing drip gas. Somebody will understand what I'm saying out here. They will. It's the same as passing liquid natural gas or drip gas through oil, sour crude. It'll sweeten it up. So when you pass the mix that's starting to get burnt, but is still lubrication on the bottom half of the piston at the bottom of the stroke and compressing it out through you can look at the green arrow there on the left hand side. It'll pass it back to the fuel and it'll sweeten it up, that gas and everything, any liquid that may or may not pass through there, and then it'll get recycled. Okay, it's not a perfect system, but that's not what we're doing. This is the design phase, not the build phase. It's expected to have mistakes here. Now, on the right-hand side, you can obviously see that because generally two strokes only have one ring. It's not busted up into the top, the fuel ring, oil ring, you know what I mean? It's not busted up like that. So, since it's a single ring, compression ring, piston ring, then what you'll have is you'll have some leakage out the exhaust port, which is okay. That can also be tapped off if you so wanted, okay, because I'm looking for we're trying super efficiency, and in this design, even though I can go a fully magnetic drive, which I've done time and again, not my newest versions, but on these I just thought, well, let's see what we can do with a mix drive, okay, which is a Bridgehead. It's a Bridgehead. Okay, so moving on, give me just a second so I can pull it up and so you can see it. Where'd you go? Bridgehead. There you go. It's a two-stroke Bridgehead V-gate motor engine. All right, technically motors are for electric motors, but yeah. Anyway, as you can see, it'll explain to you right here in front of you. Let's start with left-hand side going down. Butterfly high-speed vane. That's going to act as your turbojet, because she's going to spin up. All right. And she's going to be spinning fast if I can do it right. And at the bottom will be the butterfly turbine, though technically the nomenclature is irrelevant. It's just as long as you understand it. It'll act as a Tesla turbine in a way, okay, an impeller. Think of a propeller. How about that? All right, you got your fuel tank, and the tank's pressurized coming off the crankcase. A one-way ball check for a reason, because you don't want it being pulled back into the crankcase when she goes up to TDC. The crankcase BDC impulse port, that's just the port for the pressure line, the gas line, pressurized gases, okay, crankcase gases. You've got your air injector line as you go down. Of course, you can see the piston crank will be a mag impulse drive. That little air piston, the piston crank, will be magnetic. And air piston, okay, moving. It shows your crankcase, then it shows your crankcase V-gate. Remember, this two-dimensional, but of course it'll be three-dimensional, so there will be 3 V-gates, singular V-gates for the crank, but I haven't got to it yet, so just fucking shut up. How about that? I'm designing it. Anyway, the crank has, obviously, drive magnets on it. I don't know how the design is going to be, but remember, we're dealing with the idea. So the BDC case return mag, that just means the case is, got two return magnets there. Think of it as just one solid one, but it's irrelevant. Your 45-degree cylinder V-gates running from bottom to top, right to left. You'll see those are 3 big circles on the crank case there, the head case, you know what I mean, mid case. Those 3 are meant just to bounce the piston back up. She slides down quick, gaining speed off the first 2 magnets, and she bottoms out on the BDC return mag, and then boom, because of the size of the 3rd V-gate magnet on the cylinder, she pops back up. So I'm trying to eliminate as much fuel usage. Anyway, BDC mag for the piston, just a piston mag. Of course, your exhaust port and a TDC mag. And you got your magnetic head and your spark plug and magneto. Remembering this is for an aluminum block, which is so common now as to might as well just go ahead and use them. All right, moving on to the 3rd. Okay, now this will show you a more full version of fuel and airflow. I've changed it here. Your fuel's red, air is yellow, crank gases are green to give you a more full version. All right, let's follow your reds. Primer, it shows you up into the primer, down, pressurizing the tank when you prime. Remember, as soon as you turn over the motor turn the motor over with your starter. Right now, the starter will just be a rope starter. We're just talking simple right now. Okay, passes through, etc., etc. You can see it. You can see how it works there. So I'm not going to waste any more time on it. The external air is where I added in the external air port. Not a big deal. Not a big deal. That's 3. Let's go ahead and move to the carburetor. We'll begin with the simple version. That's just showing you the simple design. It's not fancy. That's the regular design there. And we begin to go into the nomenclature and terming it out. So we'll move into this. Will begin to show you Bridgehead carb. The carb body will move left to right, top to bottom. We'll just do a big circle clockwise. Carb body, butterfly shaft goes through all the way through the center. The butterfly plate acts as a turbine. All right. Moving to the right, you have an intake standoff from the block. Okay. Other people know what I'm talking about. It's just a standoff in between the carb and the intake. All right. You've got your piston block right there showing your intake port. Not a big deal. Moving down, that's your impeller body. It's separated from the actual carb itself. The carb is just super simple Venturi, but it's pressurized this time around with the hopes that it would use less fuel, especially with atomization. Moving down, impeller ported turbine. The impeller plate there on the horizontal has a port, so it'll act kind of like a Tesla turbine, but it can also be in other versions. It's not a big deal. It could be redone. The crankcase gas and all that pass through that port. On the bottom, the atmospheric intake port. Moving over to the gas piston outlet line, which is going into, then passing through, and then coming out the crankcase gas vent. All right, and over on the left-hand side there, atmospheric intake port and the fuel line, which is pressurized. Okay, that's just giving you a basics of what is what. Now, this will show you the fuel flow. All right, the fuel flow is red, airflow is blue, crankcase gas flow is yellow. All right, so start on left, go to right, and we'll work from top to bottom. On the left-hand side, there's your fuel flow coming in, hitting your turbine, which is speeding up. Okay, so what you'll see is as you speed up, the turbine speeds up, and as you ease off, it eases off on your throttle, which, depending on how you want to look at it, remember, I'm not actually adding in a throttle to this, so you're missing a chunk of it, but that's not a big deal. What it was supposed to be is it will speed, to show the basics of the turbine will speed up and be able to pull more fuel in, atomized, etc. And when she slows down, she'll ease off on the fuel consumption. Okay, just normal stuff. All right. Anyway, moving in, she'll pass through to the firing chamber. The blue, the airflow blue, she's coming into the fresh air atmospheric port, passing through, mixing with the fuel. Not a big deal. On the bottom impeller side, crankcase gas flow. She's coming up on the bottom left-hand side, passing through that impeller turbine port, and coming back out. Okay, and the fresh air port's passing through as well, just in case, because you don't want to have a vacuum lock. Therefore, you're going to have to port it to fresh air, atmospheric air, so it'll pass out. So, anyway, there you have it. Of course, remember, this doesn't actually have a throttle yet, but who cares? It was the designing of it that was the important point. So, you kids have fun and take it easy.